Hi, let's talk a little about binary and hexadecimal numbers and how we can use them. The binary number system. We're used to using the decimal number system. In the decimal number systems, we have 10 symbols, 10 numerals. We count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The reason why we do this is because we have 5 fingers on each hand. When people learn how to count, they count on their fingers, so we use decimal numbers. We would have been better served to actually have been born with either 4 or 8 fingers on each hand when it comes to dealing with computers, but we were given 5 on each hand. Computers use the binary number system. The reason for this is pretty simple. All that a computer really is logically a bunch of light switches. So how many signals can we send with a light switch? We can turn it on. If we turn it on, we're going to call it a 1. We can turn the switch off, we're going to call that a 0. So basically everything stored inside of the computer, everything the computer deals with, is just one long sequence of zeros and ones, which are being sent by switches. One problem with the binary number system is since there's only the 2 numerals, if you look at a long sequence of zeros and ones, it becomes very, very confusing. All the zeros and ones kind of blend into each other. For example, look at this number. What would the odds be that you could memorize this number or even copy this number correctly without making a mistake? It's going to be very, very difficult. So, this is why we use hexadecimal. Hexadecimal numbers have base 16. If you're counting in hexadecimal, you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then A, B, C, D, E, and F. So A is equal to decimal 10, B is decimal 11, C is 12, D is 13, E is 14, and F is 15. But why we like hexadecimal numbers is that each hexadecimal number is equal to 4 binary numbers. As an example, the binary number 1110 is equal to E in hexadecimal. So this means we can represent a really long binary number by using 1/4 as many numerals if you use hexadecimal numbers. So we always use hexadecimal numbers when we're referring to binary digits, binary numbers. To convert between binary and hexadecimal is very, very simple. All that we need is a conversion table. What you're looking at here is a table. We have a list of binary, so binary 0 and what the hex equivalent is. So for instance, binary 0011 is hex 3, or binary 1111 is hex F. Converting between these is very, very simple. Look at this binary value. All we've got to do is divide this into groups of 4 digits starting at the far right. It is important to start at the far right. So we divide them into what are called nibbles, 4 bits. Once we do this, all we've got to do is look at our chart. So for instance, 1000, we look on our chart, this is an 8. 1110, this is an E. 1011, this is the B. So this is very, very simple, trivial exercise. So this long, ugly looking binary number can be represented by this much shorter hex number 8EBA52252F. It's still fairly long, but it's much easier to deal with than that long string of binary numbers. If we want to go the other way, it's just as simple. Let's say we want to change the hex value 14AC into binary. All we've got to do is check the 1. Hex is equal to 0001 binary, 4 is equal to 0100, A is 1010, and C is 1100. So 14AC is equal to that binary number. So converting between these is very, very simple, which is why we like hex. It allows us to represent large binary values as much shorter hex values, and changing between them is trivial. One other exercise that we should do is learn how to add hex numbers. Hex numbers are used to represent addresses, and we do need to add addresses. So this is pretty simple too. It works the very same as decimal numbers do, only rather than counting from 0 to 9, we count from 0 to F. So the 0 to 9 is the same in both systems, hex and decimal, but A is equal to decimal 10, B is 11, as I said earlier. So let's see how we can count in hex. So this is basically a hex number line. We've counted from 0 to F, and then from 10 down to 1F, and then you go from 20 to 2F, and then 30 to 3F, and so on. But in order for us to be able to add numbers, all that we need is the values from 0 up to 1F. So as an example, if we wanted to add 2 to F, you could just go to F on the number line, count over 1 to 1, 0, count over 2 to 1, 1. So F plus 2 is equal to 1, 1. To add A to B, just go to B on the number line. Remember that A is equal to 10. Just count over 10 from B, and you get to 1, 5. And for larger numbers, we can do the very same thing, just add each column individually, just like in decimal. So let's say we want to add 4E5 to B6A. So we're going to start at the far right column, add 5 to A. 5 to A gives us F. Then we want to add 6 to E. When we do this, we see that that is equal to 14. So we write down the 4 and carry the 1 to the next column, just like we would in decimal numbers. Then for the last column, we have B plus 4 plus the 1 that we carried in, so B plus 5. If you look on our chart, the B and add 5 to it, it comes to 1, 0. So 4E5 plus B6A is equal to 1, 0, 4F. Well, that's pretty simple.